Hello, everyone, and welcome to Kilowatt. My name is Bodhi, and I am your host, and we have finally made it to the Part 3 Investor Day Kilowatt something extravaganza. I'm not really sure. I've spent a lot of time listening to Elon and the team, and my brain is jello. I don't have much left over in terms of brain power. Like this is a lot. But what I do have is I have thanks. I have thanks for people who help contribute to the show. So I want to thank Tommaso, Ryan, Chip, Chris, who's been supporting this show since April 2019. Because we have two Chris's and a Christopher. I don't know how to. We have two Chris B's even. So I don't know how to say thank you to both of you, but thank you every Chris. Thank you. Sierra, my Sierra, who I saw today, and maybe we'll have on the show soon. Dale, Don, Cameron, Nate, Mark, James, and David. Thank you everyone for supporting the show. In February, we lost a few people, and that's okay. Like, I get it. Like, people come and they go, and sometimes they support for a little bit, and then they stop, and then they'll come back and support a little bit longer. And that's totally okay. But I do want to thank everybody who is either currently supporting the show or has ever supported the show, even if it was for a month and you still listen to the show. Thank you so much for supporting this show. I really appreciate it. It means a lot to me. Okay. Here's the deal. Elon and Tesla are being sued by shareholders over Tesla's claims about autopilot and full self-driving safety. Shareholders are seeking unknown damages on behalf of shareholders of the company from February 19th, 2019 to February 17th, 2023. And this is just basically based off of a National Highway Transportation Safety Administration. I don't know if it was a requirement or they forced them to do this, but basically Elon and the team had to admit that full self-driving is level 2. And when we get into the news next week, and yes, there will be news next week. I can't remember what I've said over the last couple of days, but next Friday we'll have news. When we get into that, I'll give you more information, but I do want to let you know that that is happening. All right, let's get into part 3 here. Let me scroll down to get to my notes. First up, we're going to have a short clip with Drew Bagliano, and he's going to talk about cell production.
First, I thought I'd just provide a little bit of an update on cell production. So remember Battery Day, we showed this video with the spoon and how we went from dry powder to film. Let's just say there's no spoon now. So many of you in this room saw this on your tour today, but here is our dry electrode machine here in Texas, one of the lines we have installed here. Fully automated, no spoon, from powder and foil in to coated electrode out. From a peak productivity perspective, per tool perspective, this is over 20 times the productivity of the tools that we showed folks on the tour in Cato back in Battery Day. So we've made a lot of progress on one of the key parts of the cell manufacturing process. And we've also continued to focus on refining the way we make cells and the factories that the cells go inside. As you can see on this chart, from typical 2170 cylindrical cells to 4680, we made a huge leap, which is basically a 5x reduction in the factory footprint and volume and footprint. And then from going from what we did in Fremont and our pilot line to Texas, we improved further, and we're improving again when we go into Nevada. And what this actually represents is a series of actions taken by a very integrated, holistic design team across the product design, the manufacturing design, the process design, the equipment design, and the facility design. They all need to work together to make this happen. And you can see on the bottom, just as an example of simplicity up, investment down, and scaling up. Parts, we've reduced the number of parts in the cell, the number of processes, significant reduction in the number of processes, and collaborating with those 5 design groups, we've been able to end up with a factory that's 10 times smaller volumetrically, which means it's faster to get built. It's much lower capex per gigawatt hour output, and we can go and scale, to our objectives of, 240 total terawatt hours, 1 terawatt hour a year of stationary storage, and 20 million vehicles a year, with the scalability that is required to achieve our goals. And we're not just looking at the cell factory itself, but also upstream materials where necessary. What you see here is the rendering of the 50 gigawatt hour a year Corpus Christi lithium refinery that we've already broken ground on here in Texas. The facility will start commissioning by the end of 2023, this year. This is a good example of something where we're basically talking about breaking ground and starting commissioning within 10 months, and with actual production within 12 months. That's the target, similar to what we did in Shanghai. Again, the result of collaboration and internal execution of construction, in partnership with local communities. This site is 30 minutes from the Corpus Christi port. It's located directly on rail. The process route we're taking is a direct soda ash leach of the input material, which means there's no acid roasting. We don't have any of the sort of waste products associated with an acid roasting step. We're designed to consume lithium spodumene, which is a very commonly traded lithium rock, but it is flexible to other feeds from primary and secondary sources. And similarly, we're working on our cathode facility here in Texas. Maybe you've seen it as you're driving around, which is a 60 gigawatt hour a year cathode facility behind the main building here. 10-month build time there as well. The equipment's being installed for the first line as we speak, and we'll be commissioning starting next quarter. So we are doing this where we need to. Our plan is not to do it always. There are lots of competent companies out there, but we are also trying to sort of accelerate the pace of the industry by trying some new things that are a little bit more scalable, and de-risking certain innovations that improve productivity in terms of capex per gigawatt hour and things like that.
All right. I don't think that I knew that Tesla had a lithium refinery in Corpus Christi, Texas. Maybe I did, but 50 gigawatt hours of lithium coming out of that area by the end of 2023. So that's great. It was nice to hear as they're able to scale the sales up, the factory footprint shrinks. So I like that. We're hearing a lot about efficiency and deleting processes that aren't needed and making things smaller. So that's great. And the 4680 cells are a work in progress, but it sounds like they're getting there. Next up, we're going to hear about Tesla Energy's retail future. And I'm going to be honest, I cut the heck out of this clip because it was very long. One thing about Drew Bagliano, he's very interesting to listen to, but he likes to talk a lot. So I had to cut some of his clips down quite a bit.
Maybe some of you know about this sort of retail plan we have here in Texas, and I just wanted to talk a little bit about how that all fits together. So Tesla Electric really unlocks the full value of distributed energy and storage products. So it enables our customers to become their own utility. The data on the page is from our South Australia virtual power plant, another Tesla Electric setup that we have. Over 2022, it's 5,000 customers that we have the data for. You can get a sense for what's happening. So just if they were being provided default utility service and you looked at the cost of serving them that electricity, on average, $140 a month. If they all had solar and Powerwall, but the solar and Powerwall wasn't interacting with the grid, wasn't participating in the energy market, the cost of serving that customer would go from $140 a month to $70 a month. If Tesla Electric is operating those assets in an intelligent way to benefit the grid, Tesla Electric being basically a software that we developed out of AutoBidder for the purposes of these distributed energy resources, we can actually pay the customers to bring their energy services to the grid. That's what happened in Australia last year. And Australia is a little bit of a special case. They represent the future, South Australia in particular. Solar and wind supplied 70% of South Australia's energy in 2022. That compares to 30% in Texas and 35% in California. But this is an indication of where this is all headed, of both centralized and distributed storage resources providing the key to unlocking fully renewable grids. And Tesla Electric is the retail plan that we're using to bring that to bear for our customers that have our products. And this is how we're rolling it out. First, as it exists, it's available in Texas for people who have Powerwalls in their homes. But we need to extend beyond that. Over 1 billion people live in markets with competitive retail electricity. And there's over $2 trillion in annual energy spend in these markets. This is a huge opportunity. And our intention is to bring this to, market by market in the same way that we've approached Tesla Insurance, where we can bring value to our customers to reduce their total cost of ownership of our products. So actually what we're going to do next, and this is pretty exciting here in Texas, by this summer, we're going to offer a retail electricity plan to people who have our cars where they can have unlimited overnight home charging for $30 a month. This is part of reducing the total cost of ownership of our vehicles. And the reason why we can do this is because Texas has a ton of wind. And in Texas, the wind blows at night. So actually serving these customers with electricity at night for their cars is the best thing to do for everyone. And so this is a way to incentivize people to charge at home at night directly from renewable power. It's part of the grand master plan we talked about at the beginning. So we're very excited about this. And we do see this similar to Tesla Insurance, as I said, as further reducing the total cost of ownership of electric vehicles. So putting this all together, we're really at the beginning of this massive ramp in energy storage deployment. And
yeah, reflecting back on the master plan, we talk about needing tens of terawatt hours of stationary storage. So we have our sites set on annual production rates of 1 terawatt hour, which is 25x our capacity at Lathrop. In the near term, we see really strong demand for the Megapack product, over 100 gigawatt hours per year in 2023, and growing by over 100 gigawatt hours per year over the next few years. So the demand is there, and naturally, as we continue to focus on cost and speed and value, the things that we've mentioned, it's clear we need to build more capacity and we need to ramp it quickly. So while the challenge is big, it's also a huge opportunity for Tesla. It's a huge opportunity for the Megapack business. And I'm excited to see the impact that it's going to make on our grid transition.
I love that Tesla is able to pay customers in Australia. That is fantastic. I'm not sure how many other countries that could happen in a meaningful way. Not because I don't think it's possible. It's just because I just don't know the ins and outs of every country and energy and what their needs are versus what they can produce. So I think that's pretty cool, though. I would love to get paid to have solar panels and a power wall, even if it was just a couple dollars a month. One of the things he talked about was the Texas plan for overnight home charging for $30 a month. You get unlimited overnight home charging for $30 a month. Here's my question to everybody who's got an EV out there. Does this make sense to you to pay $30 a month for this if you only have one EV? I can see this maybe being an advantage if you have two EVs, but if you only have one, is it better to just not do that? I'm curious. Email me, Bodie, BODIE at 918digital.com. All right. We had some folks from HR. They talked about Tesla employees in a really positive way. They put, the spotlight on the employees. I think that's great. And Tesla has 129,000 total employees. And like we mentioned in one of the other episodes, 65,000 about of those are manufacturing employees. Pretty impressive. Next up, we are going to we're going to hear from Zach Kirkhorn. And he's going to talk about how Tesla is removing costs. And I chopped this one up as well.
All right. So this is our last section of our prepared remarks today. We'll kind of take what we've discussed today and summarize it at the corporate level for our financials. Maybe before I jump into the details here, we've never done an investor day as a company. We've never brought our leadership team out and asked them to talk about the things that they're working on. So, I feel very fortunate to be able to work alongside this group of people and support their teams. And I also just want to thank them, they're in a room in the back listening to this, for all of the work that they put into today and getting the company to where it is today. So thank you to the Tesla team. When we were preparing for today, folks were asking, well, Zach, what should we talk about? And really the only guidance we gave folks is, well, talk about the things that you're working on and talk about it in the context of the master plan. And what did almost everybody talk about today in great detail? All of the work that they're doing to take cost out. Because in this industry, in this business, you survive or you die based upon the ability to manage your costs. And so I'd like to talk about cost as well. If we look at our longest running scale production product. This is the Model 3. We reached 5,000 cars per week, which was our design capacity in mid-2018. And since then, we've taken 30% of cost out of this product. And there's 2 points I want to make about this. The first is that cost reduction, as you have heard throughout the course of the day, is deeply ingrained in our culture. And I think one of the most important reasons why we are here today as a company. The second point that I want to make is that when we're working on cost reduction, it's easy just to take cost out and make our products worse. But we have to take cost out and improve our products at the same time. This is the hard thing to do, but it's the necessary thing to do to continue to move forward. And if you look at a version of a Model 3 that we built today, and you compare it back to a Model 3 that we built in 2018, there's a long list of improvements that we put into the car while also taking cost out of the product. Cost reduction doesn't just come from one place. There's no silver bullet here. And we pushed the boundaries on volume with the Model 3 program, increasing volume 3x over this period of time. We've improved productivity. So in our Fremont factory, we are twice as productive now as we were in mid-2018. We've made a lot of progress on overhead efficiencies and product improvements, as we've discussed, and a long list of other things, including localization, our factory in Shanghai. And as we ramp up volume and as we find efficiencies, we work with our suppliers to do the same. And that leads to material cost reductions that improve the affordability of our products. And as we look forward to our next-gen vehicle, our target is to reduce 50% of cost, and we've talked about that a bit earlier today. Going from the Model S and X platform to the 3 and Y platform, we took out 50% of cost, so the task here is to do it again. And this is very important because as we improve affordability, the number of customers who have access to our products dramatically increases. And as we link this back to our master plan, it enables an exponential growth in our volume with linear reductions in the cost of our products. The second point I'll make here is that, and again, cost reductions don't come from any single one place. And so you can see the buckets here on the vehicle side, battery and powertrain, manufacturing cost reductions, and others. These buckets are relatively equal in size. And so in order to take 50% of the cost out of the product, we have to go through everything. But more importantly than just the cost of the car up front, when we're transitioning to a sustainable economy, particularly with vehicle ownership, it's really important to think about the lifetime cost of the products. And this chart here is showing what the total cost of ownership per mile is over the course of 5 years. And we have to think about financing costs, insurance costs, the cost of power. Drew talked a little bit about that with the plants that we're doing in Texas, wear and tear and maintenance on the cars, etc. And we're already at a place today in the US where a base Model 3 on a cost per mile basis is less than a Toyota Corolla, which is the highest selling car in the world. And as we move towards our next-gen platform, we will continue to reduce this. And as we work on robotaxi variants of this platform, this cost will come down even further. And so this is a product that we expect to have substantially lower cost per mile than the highest volume products in the world. So all of this work on cost reduction is extremely important because we have a lot of money to spend ahead of us to achieve our goals within the master plan. So we've mentioned over the course of the day today, 20 million annual vehicle production as our target, 1 terawatt hour of annual energy storage production, and then expanding cell production, service, and charging in line with the growth of those other businesses. And so we've estimated what we think the total cost to get there will be. And there's certainly error bars around these numbers as we continue to progress and innovate. But of this, we've spent about $28 billion of that so far in the history of the company. And maybe this total investment looks large. I actually think it's quite small relative to our ambitions. And if you look at our 2022 operating cash flows and you just say, well, let's assume some modest growth to that, maybe not all that much, if you're being conservative, but the ability to pay for this level of investment from the forecast that we have is very achievable for us. So to wrap up the finance portion of the presentation today, a couple of key messages I just want to leave you all with here is that we use innovation at an intense level to drive costs down and improve the efficiency of the business. And the reason this is so important is it allows us to improve product affordability. And this is particularly the case when we move to our next generation platform. Improving affordability allows us to comfortably make investments that grow volume. That volume generates cash that then allows us to make more investments. And as we integrate that going forward, it's our belief as a leadership team here at Tesla that we're going to achieve unprecedented scale in the manufacturing space. And this is what's ultimately required to accelerate the world's transition to sustainable energy.
All right. I really like hearing about this stuff, and hopefully you did too. He did talk about a bunch of other financial stuff that isn't appropriate for this show, so I cut it out. But 30% of the cost was removed from the Model 3 since its launch in 2018. That is very impressive. And they did this all while improving the product. And how did they do it? Well, the volume growth, they were able to scale up and reduce those costs, improve productivity, overhead efficiencies, product improvements, engineering changes, localizations, and supplier scale. That is fantastic. Zach talked about what kind of investment they need to make in order to hit their goals of 20 million annual vehicles a year, 1 terawatt of energy a year, and expand their cell production. So this is going to cost Tesla somewhere around $150 to $175 billion is what they need to invest to make this happen. Currently, to date, they've invested $28 billion. That's pretty impressive. And this is all funded by operating cash flow. Now, in the past, they've had loans and things like that, but I think that what he means is currently. All right, next up, we're going to get to the questions section. Our first question is, when are we going to get the next generation vehicles? So let's go ahead and listen to that.
It's Rod Lash with Wolf Research. Very exciting plans about the next generation vehicle and powertrains and batteries. I was hoping you can maybe talk to us a little bit about the timeline for deploying this. And it sounds like it's more than just a vehicle. This is a kind of a paradigm change on how vehicles are assembled, how batteries are put together and everything. And does that also just get reconfigured into everything that you do? So the Model Ys that are being built here will be built very differently in the future. Maybe just give us some feel for what happens from here and what's the timeline for implementation.
Well, I'll talk a little bit about that, but broadly speaking, the most profound architectural changes will be in future vehicles. Retooling a factory means bringing the factory down for an extended period of time, and that would prefer not to do that, I think. But there are variants in how Model Y is produced. So we've got variants where there's rear casting, where there's a front and rear casting, and we have the structural battery pack. And then there are a number of smaller improvements that occur. But I think for really, really big changes, those would be future vehicles. Yeah, I don't know, you guys want to add? Lars, maybe?
Me? Yeah. So, I mean, as far as, yeah, I agree with you 100%, Elon. It's really easy to put innovations in new vehicles, but long term, we'll obviously bring them back. We've always talked about that, but we don't want to take our factories down. As far as the timeline goes, we're going to go as fast as we can, left to right. As always, Elon alluded to the fact that Mexico will build our next gen vehicle, but we will also be doing that in our other plants. And so it's really about getting them all up and running. We expect that to be a huge volume product, and we're going to move that quickly over the next couple of years.
So I watched this presentation twice. Once was just all the way through as Tesla was streaming it, and the second time was preparing for this show. And oftentimes I had to go back and make sure I heard things correct, and then I had to look stuff up because I'm dumb. I did not put together that the next generation vehicles would start in Mexico. I did hear that the next generation vehicles would be built in Mexico, but I didn't put together that they would start there. So I wonder, because we have a bifurcated Model Y, Elon talked about it, and it's probably trifurcated, if that's actually a word. But there's several different versions of the Model Y that are being built currently. I wonder if there'll be a Model Y line in Mexico, a Model 3 line in Mexico, and those vehicles will be using that next generation technology. And then Tesla will be building that next generation of vehicles alongside those legacy vehicles, which is weird to say that the Model Y and the Model 3 are now considered legacy vehicles. I'm really excited to see what Tesla comes up with. Next up, we're going to hear from the team on bidirectional charging.
Thank you. It's Philippe Bouchot at Jefferies. I've got two questions. The first one, when I think about in this industry, everybody wants to be Tesla. Every car maker is trying to emulate what you're doing. Well done. The one thing they don't do is focus on having as much growth as possible with as few models as possible. So I'm just trying to understand, as you aim for 20 million units in 2030, how many models do you think you need to get there? And how does it fit into your drive to hyperscale? How do you manage this? And also the fact that probably consumers at some point don't want to see a Tesla or the same Tesla at every street corner. So I'm just trying to get your sense of that. And my other question is on bidirectional. I mean, you talked a lot about making, a world more renewables and better usage of cars. I think bidirectional charging is one way of better using cars, but you seem to have been reluctant about doing that in the past. So I'm just wondering what your latest views are on the topic.
Sure. On bidirectional, it wasn't like a conscious decision to not do it. It just wasn't a priority at the time, I think is maybe the way to think about it. As we continue to improve the power electronics in our vehicle, we've found ways to bring bidirectionality while actually reducing cost of power electronics in the vehicle. And as at all things Tesla, the goal is usually to get more for less. And so we are in the middle of kind of like a power electronics retool, I would say, that will bring that functionality to all of our vehicles over the next, 2 years, let's say. But I guess that's how I'll say there.
Yeah. I don't think very many people are going to use bidirectional charging unless you have a power wall, because if you unplug your car, your house goes dark. And this is extremely inconvenient.
Yeah, most of the value, it comes in charging the car at the right time. It's not really about sending energy the other way.
Yeah, I mean, if you have a power wall that can take the house load, then you can use your car as a supplementary energy source to the power wall, and then you're not going to drive everyone crazy by unplugging your car and having the house go off. So I think there's some value there as a supplemental energy source down the road, where if you have a power wall, you've not diminished the convenience of the people in the house.
I'm going to be honest. I didn't love that answer by Elon. If you unplug your car, the house goes dead. Well, that's not entirely true, because there are times when you just may want to offset the house during peak energy times where you're going to pay the most amount of money. So maybe you do want to offset in those situations with your battery. And then in the event of an emergency, just having the ability to plug your car in if you don't have a power wall and get your family through the hottest or coldest parts of the day, or be able to run the refrigerator or whatever, that's pretty valuable. And yeah, you might have to unplug your car and go somewhere else and charge it and bring it back, but that's okay, because it's better than the alternative, which is like the snowpocalypse, which Sierra and Brad were in, and they ended up just sleeping in their car instead of being in the house that they rented. Here in Arizona, it would be absolutely awful if the power went out for any length of time. And granted, I don't think I'd be able to run my air conditioners on it, but I could go to Home Depot, I could buy a small window air conditioner, and we can all just stay in one room. I mean, we can figure it out. So I don't think that bidirectional charging is useless. Having said that, I don't love the idea of bidirectional charging. I think it's good for an emergency. I don't think it's good for everyday use. And that's my opinion. I do not base that in fact, but I would rather keep my battery for my car, strictly for my car, and I'll degrade that over time by driving the vehicle, not by running my house unnecessarily on it. All right, we're at our final clip, and we are going to talk about dry battery electrode. So let's listen in.
Alex Potter with Piper. So I definitely want to ask Drew or anybody else up there for an update on dry battery electrode, right? So if you're going to try to overcapacitize towards cells, scale a lot of this, clearly there's a lot of moving pieces and it's a complex sort of orchestra with the supply chain, but a lot of it comes down to dry battery electrode, at least to me. So how are you trending? That was the most fascinating part of the factory tour for me, and looking through that window and seeing that this is clearly not a science project. But anything that you're willing to disclose, yields, progress, where you are today versus where you thought you were going to be.
The dry electrode problem is really quite a hard problem. We acquired Maxwell really just for the dry electrode technology, but just illustrates what a gigantic gap there is between something working at small scale and at large scale. And we've had an extremely talented team of engineers working on scaling the dry electrode process and having it be reliable and consistent. And we've been grinding hard, literally and figuratively, on this for quite a while. It seems likely that we will be able to scale it to volume this year.
So it sounds like it's coming along. They're figuring things out, and I think that's fantastic. All right, everybody, that is it for me this week. Can you believe that we got this episode done in under 35 minutes, provided I don't continue talking for very long to wrap this all up like I'm doing right now? I want to thank each and every one of you for listening and being patient with me as I release these on a daily basis. I know this is a lot of information, and some of you aren't going to listen to this, and that's totally fine. If you did listen to this, send me an email, Bodie, BODIE at 918digital.com, and I will send you kilowatt stickers. One of the stickers one of the stickers was designed by Allison Sheridan, and the other was designed by me with help from Allison and Steve Sheridan. So let me know if you finished all 3 episodes, and I'm taking you for your word. Send me an email. I will send you 2 stickers. And Mark, I sent your stickers today, just so you know. I got to figure out a new way to end this show because it's always awkward. So I'm going to try something out here. And this is just off the top of my head because I just decided to do it right this second because I couldn't think of how to end the show, as you can tell, because I'm still talking. But for the Kilowatt Podcast, I am Bodie Graham. Good day. Was that lame? It was lame.